at SOM, lived and worked abroad in Abu Dhabi and India, and then spent a bit more time in Chicago. Now, as was mentioned, I am Chief Design Officer for Skender. Skender, up until about 9 months ago, was a construction company. And what we realized over the past 3.5 years, the firm that I led and that organization, a couple other organizations, we were looking at co-investing in a new manufacturing facility. So we started to ask what it looked like to actually push prefabrication, off-site construction, and really manufacturing into a way that sort of functioned and structured a little bit more like every other designed object industry. That led to about 9 months ago, that organization realizing that 5 years from now, if what we're talking about actually happens, if this is the way the industry goes, the wonder was what the core business model might be. The core business model actually changes. So that's what's led to this integration. We're building a 105,000 square foot facility on the southwest side of Chicago. And we're really looking at what it looks like to maybe solve some of the ways we put buildings together in maybe a different way. So with that, I really want to talk about how we build now and maybe where we could go going forward. I start with this because according to Wikipedia, which is always true, and there's no inaccuracies on it, 32,018 years ago, somebody took a rock and tied it to the end of a stick and started hitting stuff with it. And what's really interesting is that some of the biggest advancements in day-to-day construction are shock-proof handles for that stick so it doesn't hurt as much when you hit stuff with it. It makes you start to wonder how we sort of operate, how we do things differently when we think about things that are happening at the university level, at the research level, and frankly, again, every other designed object industry in the world. So I just want to think about what's happened over the past 9 months. Over the past 9 months, scientists have invented a robot that swims by itself and finds lost schools of fish and then helps those schools of fish find their way out. All right, so we have autonomous robotic fish that are guiding other fish in the ocean. That's really cool. We have autonomous helicopter Uber vehicles that Dubai has announced they're going to be rolling out in a pretty meaningful way. So all right, so we can lead schools of fish underwater. We can have helicopters fly us around. We even have a sort of concrete that absorbs the sunlight during the day and emits that light at night. So that is something that's coming into production in 2018. And frankly, one of the most exciting things in architecture is that Kanye West has announced that he is an architect and is forming an architecture studio. So the world is changing around us, and the reality is this is kind of what it looks like. This is kind of what it looks like. These are the realities of how we put buildings together. This is the reality of what we do when we intend to make the built environment better. We put up sort of complicated structures, we barricade off streets, we shift and turn, and we're still putting things together piece by piece by piece. And we result in situations like this. So just as a frame of reference, this is a renovation project. It's a 340,000 square foot office renovation. That's what came out of the building in order to make a new one or to update it. So even the way in which we operate has massive issues and holes in it. I'll even go back to my dear friend Bob Vila, who is instructing people to use in the rain, obviously, it was probably today, soaking rain, dripping wet, and they've got a saw pointed straight down at their feet. So there's some complexities in the way that we build buildings. There's realities of how building construction as we know it operates and works. And there's even, in moments like this, in moments where the most organized projects, where that sort of information coming from design is really informing a clean and crisp way of building, it's nowhere near something like that. Something that is putting together the most advanced, energy-efficient passenger airplane in the world at large scale. Right? We're looking at a very small portion of a large assembly line. And when I say large, I don't mean just in this building. This is final fabrication. This is assembly of all the parts and pieces. But all those parts and pieces, like the wings, for example, they go in a dream lifter, an airplane even bigger, and they're built off-site at a different location. The body is built in a different location. The engines and the interiors are all built in different locations. What you actually get here, and what's rather interesting, is that this is not the construction of an airplane anymore. This is the assembly of that airplane. All the parts and pieces come together to make something far better than what we had done in the past. So I wonder then, if we start to imagine what a plausible future of the way we build cities looks like and acts, I think it's less like what maybe Blade Runner would suggest. Oh, that's a video. I think it's more, that was about teamwork, but it's a team that was losing. I think it's more like this. I don't think it's necessarily building Lego cities or building buildings that look like Legos. I wonder if the way we build things ought to look a lot more like an automobile assembly line. You know, a Toyota assembly line produces a car every 57 seconds. Every 57 seconds, a sort of high-performance combustible machine with heating and cooling and wheels and shocks and springs is built in a factory and to full code and regulation compliance. In fact, a little over 50 years ago, almost every state in the United States had very specific automobile code and regulation. And what happened through some of the efficiencies that you get out of processes like this is you end up with this future state where you can design to the best possible version of what that car is, and there's very few regional changes. There's an understanding that something like the IBC actually has relevance place to place to place and location to location. There's an understanding that you can use materials that are best in class because you're using them at scale. And you know, don't get me wrong, there's been an effort to really think about how you go vertically with modular and prefab. This is one of my favorite examples. I really love it because if you look at it, it's actually precast highway tees. Somebody spent a little bit of time trying to solve this. But I wonder if there's a better way. I wonder if there's something that looks a little bit more like this as a studio and a little bit less like what we saw. So here's an example. This is in Carmel Place in New York City. This is a project done in Brooklyn and shipped to site. Now it's a small scale version of it, but what gets interesting is that the final form is a solution that looks a lot like interesting architecture, right? It's replacing a traditionally built building with something built much better. And in fact, maybe that's a cultural shift too. Do you know that the average laborer that works on a project goes to 15 different locations over the course of a year? And more often than not, they eat their lunch in their car. More often than not, they are in locations where they have to put something on their head to protect themselves. They have to put, they sometimes even have to clip in so that they don't get blown off a building. The realities of construction are very complicated. And frankly, as designers, the reality of how our design ideas come into fruition are often muddied by the realities of how we deliver buildings. This is the site of the Pullman car plant outside of Chicago. What's interesting about this, and what's interesting about these ideas of factory and manufacturing-based buildings, is that you can take a labor force, a workforce that is sort of dwindling and shrinking, and you can give them a stable job that starts at the same time every day, that ends at the same time every day. In fact, one of the things that we're doing right now, we've just negotiated a manufacturing labor agreement. So we're running a factory in Chicago that is 100% union and at the same time is creating a next generation pipeline for new employees. Employees that can potentially buy the affordable housing that they produce. We see this all over the place. There's lots of really interesting examples. Many examples not far from here of better ways to build, of leveraging indoor environments, of climate-controlled environments to build in more interesting ways. We can stack buildings that look a lot like the buildings we know, but are done a little bit differently. We can start to make boxes out of them. We can start to stack boxes and insulate boxes and treat them differently. You know, here's the thing. One of the most captivating parts to Tesla as a company to me was that their effort was to build an autonomous vehicle. What they started with was a vehicle that anybody could drive because it has a steering wheel, it has a window, it has a gas pedal, it has a brake. It's very familiar. A dear friend of mine and somebody that Phil and Andrew know in Chicago asked me this. They said, look, if I were building a factory to do any sort of prefabricated building, I'd do the wild, most crazy buildings I could imagine. I'd stack them every which way. And I would say, you know, eventually we'll get to something like that, but let's start with replacing what we know now with a better version of what we know? How do we make it familiar? How do we remove some of the association that comes from this typology and shift to better buildings? Because there are examples of ways that factory-built buildings can look and act a little bit more contemporary, a little bit more interesting. There are tools that come into place, whether you're building engine assemblies or whether you can start to build better HVAC systems, systems that understand how a building functions going forward. You know, there's some important lessons to be learned about passing on trade and skill, and I mentioned this a little bit earlier. Since 2008, we lost 2.2 million people in the skilled and semi-skilled trades across the country. We've only replaced roughly 1.2 million of those people. So we have a shortfall there. So while teaching people masonry, for example, is valuable, I'd rather think about the same tools that are captivating much of our economy as we shift to a creative economy. What are those tools that maybe takes those same ideas and makes them relevant, like you see just not that far from here, into the way we build things, makes them relevant in the way we assemble things. Oddly enough, it's not the most exciting thing to take an ABB robot that costs a lot of money and put it in the field. So what happens if we move it into the factory? And what does it look like to do additive manufacturing? Where does that fit in the grand scheme of things? I was just looking at a really exciting new ceramic printer. And it's not just for how we build entire assemblies, but I start to wonder how we build the parts and pieces a little bit differently. They don't actually have to look like castles for you to leverage the tools that exist. But they certainly can look much better than this. Because frankly, this is where our mind goes when we think about the power and potential of something not built in the location where it finally resides. This is a gift to you as well. I'll put that one up. There's a way to think about how these new materials, these new techniques, these new approaches can make wildly new, interesting buildings. And I would argue there's a path here then to say what we're doing right now, if we look at how every other designed object industry treats manufacturing, treats supply chain, treats materials and innovation, that we can think about what those outcomes are just a little bit differently. That we could in fact think about what entire rooms could be shipped to site. We could think about new materials. This was a very simple, pedantic example of bathrooms and exam rooms, okay? So these are bathrooms and exam rooms for a hospital that we were prototyping a year and a half ago. They're structured on a 1-inch thick aluminum honeycomb panel. It's not the sexiest of materials, but it's the same thing that airplanes are made out of. And you would never use it as the floor of a bathroom in a, let me go back there. You never use it as the floor of a bathroom at a hospital unless you determine that it is the most structurally resilient material that you can buy 100 at a time in CNC pre-cut. All of a sudden you have an assembly that doesn't require setting down into the slab. You could actually change the way you build. Now it's a funny example, but it is saying, all right, let's play with materials a little bit differently. Let's actually think about assemblies. How do we treat assemblies differently? Let's start by ganging them together and building sub-assemblies, like again you would see in most other manufacturing processes. But what you do when you look at these is you start to learn better lessons. You discover there are better ways to put these together. There's even better ways to get materials. So while we imagine not having to use sheet material going forward, what does it look like in the interim to have sheet material that's CNC pre-cut to exact dimensions? This is not just for sort of one-offs or special subsets, but it's going to be more and more the way we have to build all buildings. And if that's the case, let's move all the way forward to a better process. What does it look like when you can build entire sections of buildings and stack them together? This is one of the test rigs that we've been working on. These are 15 by 40 foot, 9 foot clear ceiling, 10.5 foot tall structural steel boxes. The first couple of buildings we're doing in Chicago are going to be erected in mid-spring, summer of next year. And these are 8 and 10-story buildings. We start to wonder, okay, how do we replace what is typically happening with things a little bit better? And at the same time, how do we replace assemblies like this, assemblies that take a lot of hard work? This is the jig to weld all those pieces together. We start to wonder what happens when we can automate those processes. Now, from an architect and a builder's perspective, it gets really exciting to have robots with weld arms working on something like this. It sounds like we're sort of pushing the edge of something. Until, again, you go back to an automobile factory and you realize that that is the only way that systems are put together. That in fact, having a robot weld something is the only way you have surety that those welds are accurate and tight. And doing it in a controlled environment is always going to be a better way to do it. So when you look at assemblies and chassis like this, you start to say, okay, where does this take me now? If I start with something like this, where can I go in a year? What's version 3.0? What's version 4.0? How do I move forward piece by piece? How do I build things not in specific stalls? So this, again, happens all the time. If we're going to build an site, we're going to treat them as individual sub-assemblies. We start to wonder what happens if you actually have them on a line. The first couple of projects that we're doing are going to be testing these new assembly methods. But in a year's time, the agenda is that we're rolling 12 building blocks a day off of an assembly line because we're going to treat it as a proper assembly line. And as folks in the United States, and especially folks all across the world have looked at, what happens then when you can apply cladding to this? This is a photograph out of Polkom's factory in Poland. What they were studying is better ways to ship entire building assemblies, including finished facades, from Poland to Brooklyn. What is that path? And then what does it look like when we start to create sub-assemblies in one location that bolt on and treat things differently? Again, a theme for us is that we're finally at a place when we take design and we take manufacturing and we take construction, we bring it all together, means that we are actually incentivized to push some of these. And it's not that far away from other industries. Other industries do this all the time, right? If you look at the creative exploration of how, let's say, a mobile phone is designed, there's two parts to it. There's the effort to understand look and feel and curve and shape. But there's something that we miss in the way we typically practice, and that is iterative improvement. Every other designed object industry in the world takes advantage of lessons learned year over year over year. What might it be then to have model years of, let's say, apartment units? I live in downtown Chicago. Downtown Chicago has a massive housing need. We can't fill the housing need with the way we build things now. Actually, most cities, large and small, have pressures around housing. What happens if you have an iterative process for model years where year after year after year, you're making improvements on the previous year's design and you're doing it at scale? You know, this idea of sort of partnering with materials and manufacturers isn't really new to our profession. There's 1,000,001 examples of it. My favorite is this one. So this is the post office, downtown Chicago. It's a Mies design building. One of the things I really love about it was that when this building was first imagined, those pieces of glass didn't exist. Not just they themselves, but the idea of making glass that big didn't exist. What that meant was in order to make a building like this happen, and frankly for a lot of buildings to happen after it, you had to take the lessons learned in how glass is floated. Mies and the contractor worked with a partner in Pennsylvania to discover better ways of floating glass to get to a point where the building could exist. And because of that, we've seen a shift even in the way glass is produced and manufactured to this day. So I'm going to do something real quick. I'm going to jump into some really I was about to say boring. Let's not use that. A lot of data points. And for those that love data, pay attention. For those that don't love data, there's pizza outside, and I'll be done with this in about 7 minutes. Just soak that in for a second. 13% of the world GDP. This has construction. What's interesting is when you look at GDP measurements, design, AEC, architecture, engineering, construction, all lump into this category. So 13% of the globe's GDP comes directly with what we design, how we think about it, how the pieces come together. And this is, it says 1% over the past 20 years, but I want to look at it slightly differently. So this is global productivity since 1995. If you take this all the way out to the late 60s and 70s, these lines don't actually change. What you see here in the middle, that sort of bluish gray line, that is GDP productivity year over year enhancements. This is since 1995, okay? What you see above it actually is manufacturing, right? So manufacturing is above the total economy. It's out, it's being out productive, or the rest of the economy is less productive than manufacturing. There we go. It's towards the end of the day. The reason why construction, the AEC industry is pulled out, and it's always pulled out when you measure GDP, the reason for that is because we haven't beaten inflation in over 55 years. So that means that our industry, because of our separation and isolation, means that inflation is outpacing our profession, and therefore we have to remove it from most measurements of GDP, or else it's going to negatively impact the way countries work. And when you take a look at sort of what that means, sort of the potential to get there, you realize that on a compounding annual growth rate, it is staying rather static. Another way to look at it, and this comes from a McKinsey report in 2017, looking at the productivity potential in the way we build things. So contracting and collaboration, this is one of my favorite things, and I get in trouble for saying this. The 2017 AIA contract document strongly suggests that an architect should never set foot on a construction site, nor should they ever have any comment on shop drawings for fear of risk and liability. So I want to frame that just at a high level. As we try to understand what we do, there's pressures around risk and liability in our industry that strongly suggest we shouldn't have a part in it. I would say the opposite is true now more than ever. Design and engineering should be baked into every aspect of what we do. And back to design and engineering, think about the tools and platforms that you are using right now to create your projects, to test your ideas, to push them forward. When you move into firms that are deeply embedded in Revit and the information that goes into Revit, for example. But the separation of how that building gets built means that that information, whether it's from Revit or CATIA or any number of other platforms, that information gets lost when you're actually building something. And the knowledge of how things are built is not included in the models that you create. Procurement and supply chain is a really interesting one. 7 to 8% potential growth in just procurement and supply chain. For us, what that actually means, our factory, we were able to negotiate with all but a couple of the unions. So 80% of our work, and Chicago's a union town as a bit of framing, 80% of our work is done by a single manufacturing union. The other 20% are by traditional trades. That at first was an issue to us. How do we do electrical sub-assemblies when we don't have electrical union as part of what we do? What we discovered is actually on that line right there. So most of the buildings that are in planning right now, our digital models are going directly out to supply chain partners, and they're building entire electrical sub-assemblies that will come 100 to a truck to the factory, and they'll bolt right in. So there's a little company called AC Delco. AC Delco is the single largest wiring harness company in the United States. They provide the wiring harnesses for most automobiles produced in the United States. But you don't think about them because they're sort of under the surface. They provide a kit, a piece that bolts into a kit of parts. On-site execution is a really good one. When you think about the fact that shifting from a day like today where productivity actually massively drops, if not stalls on a construction site, what happens when you move it on into a factory? Technology is a big piece too. As we start to align many of these pieces, you realize that there's gaps and opportunities to even change the way we do things. We were having a conversation 2 weeks ago with somebody who does power over Ethernet lighting. Power over Ethernet lighting is really cool, actually. It's sort of Ethernet cable goes in the back, and voila, you have a smart, intelligent, dimmable, tunable light fixture. They're also really expensive, unless you look at them at scale. You can imagine a room like this where all these light fixtures are daisy-chained off of maybe 2 light fixtures, where you're reducing the amount of infrastructure in the ceiling massively, and at the same time increasing the quality of the light that you have. So even in our tests right now, we're starting to see almost a 30% savings in lighting in our models based on traditional lighting and having a 10-fold quality increase in the types of lighting we do because technology allows that. And then my favorite is capability building. When McKinsey has a little footnote here, that 5 to 7% is the sort of, I don't know, there's probably other things that are probably going to work out by the time everybody's talking and working well together. Let's see, let's go to that one. This next one I think is big. Well, while we're waiting for the next slide to load, this is the reality too, that when you can commit to certain things, you actually massively speed up the process. One of the benefits that we're seeing right now in some of the partners that we're working with is that that speed increase on one particular project, we'll take a look at it, that speed increase from a developer's perspective saves almost $1 million in debt service. So all of a sudden, we can build at a faster rate with better quality materials and do it in a way that actually changes the way we operate. This goes back to that earlier point, 2.3 million jobs lost between '06 and 11, and we're not filling them up. So we're looking for other ways to do this. One of the things you'll also notice when you step back and realize the way technology has disrupted most industries is that we're not losing jobs in those industries. Actually, what we're doing is we're creating new and different types of jobs. My hunch is that folks in this school are learning how to do architecture in a bit of a different way than even folks 10 years, or 20 years, 50 years ago were doing it. You're learning new tools to stay relevant as part of this process. This is a diagram that I color-coded myself. I spent a lot of time on it. So think about this for a second. 48% of the energy that we produce on this planet goes into operating buildings. Do you know that in the mid-90s, I was about to say 1996, I'm not certain, so don't quote me on that. We're having a lot of issues with the amount of pollution coming out of automobiles. As a society, a global society, we fought back against that pollution that was coming out, the energy used by cars. And 20 years later, the automobile industry had reduced the amount of pollution coming out of the average car by something like 97%. And at the same time, we have an attitude that says the car folks, they're still ruining this planet. Look at all those cars belching out everything that's coming out the back end of them. And that hasn't changed. Actually, that number has gotten worse. So in 20 years, an entire industry has reshaped the way they operate, and we can't really point at ourselves. There's no group of people to point to fix that number. This is a fun one. This is based on Chicago. So think about this for a second. This is the amount of waste thrown out every day from every kitchen and family room and living room and bedroom of every house and apartment in Chicago. And that's the amount of trash that goes out of a construction site. Okay? So a way to think about it is that 1 out of every 5 pieces of material, or 20%, of new building materials shipped to site and paid for go straight to the trash. So think about it like the Giza Tower, right, or the Giza Pyramid, right? That amount of trash. And I wish for a place like Chicago that were correct, but it's not. It's actually that. It's 80 Giza Pyramids of trash a year. The other way to think about this is 20% of the cost, hard costs of doing a building every year going straight into the trash. So not only is it an economic story, but it is a reality of our environmental responsibility. Here's an even better version of that diagram, that style of diagram that I patented. 60% of the stuff that we ship to site is also packaging. So when truckloads come to a construction site, the vast majority of what we ship is actually not the things we want to get to the construction site in the first place. It's the way we wrap and protect those things. So if I were to go back and wonder, maybe there's a better way to do it. Maybe Henry Ford had a good idea. When Henry Ford did the Model T, they made something like 10,000 Model Ts. And the reason for it was that they wanted to get enough scale. They wanted to do enough of them that the cost would go down, that the quality would go up, that all those price points that made the Model T this amazing thing could actually play out in real life. When we talked before about sort of modular homes and trailer homes, there is a certain understanding in our industry and our profession about the lack of quality or lack of design. But here's the thing. For a planet that's facing massive crises of affordable housing, do you know in the country of New Zealand, they have 100,000 homes they need to build in the next 5 years alone just to cover pent-up demand. In Saudi Arabia, it's 1.4 million homes. In Salt Lake City, just the city alone is 57,000 homes. In a place like Chicago, it is just over 100,000 homes. We have these massive crises, and maybe there are different ways that we can handle it. Maybe this is not the way we think about it. Maybe it's a little bit more like this. What I love about this is the Tesla Skateboard, right? So these are battery packs and motors and running gear and computers and all the sort of technical bits that makes a Tesla a Tesla. And a version of this is underneath that car. It's underneath that car. It's underneath that car. It's even underneath their new car. What's really important for us to think about then is maybe what we're seeing here is there is power in having design and intentionality in each one of these pieces. But each one of these pieces is running on a platform that is interchangeable, that has parts and pieces that have been pushed farther than any other parts and pieces. One of the things, and we were talking about this on the drive over here, Teslas have shifted to these massive touchscreens for all their controls. It is the vision of the future. You can touch and interact, and it's a beautiful thing. The reality that they did that was because that's wildly cheaper from a manufacturing perspective. If you have a single display that runs everything as software versus knobs and widgets and buttons and flips, both from a quality perspective, you can make that thing faster. And from an experience perspective, you can actually add features by just updating the software. There's ways when this can start to look not only like a type of housing we could live in, but something that comes out of a factory instead of something that looks like this. I don't remember why I had that slide in here. I found it, and I like it. I love the creativity in it. I don't even remember it. We're just going to let it sit there for a second. So I'm going to leave it with this. This is the gold masters, what we're calling it, right? So on the production line, this is the standard unit for a 10-story building that we're working on right now. This was the proof that our partners, our owners, our engineering part, everyone walks through this unit to confirm that this is exactly what we're building. Because the building that we're doing has 140 of these units. This also represents maybe what it looks like to test a lot of new ideas, but test those ideas in ways that are very similar to what we know right now, to remove some of the stigma and association that comes from building things in a factory. Really interesting things like this masonry facade is, it's a Kingspan product. It's a thermally broken insulated metal panel. We get a high performance building enclosure with a thin set Belden brick. So I'm talking really specifically about the tectonics of how the building goes together. But it results in a beautiful masonry facade, a facade that can be applied in the factory. The window walls are set directly into these chassis and can have any sort of personality or attitude. Actually, for this building, one of the things I want to point out is that this is for an affordable building. We're running VTEX, so a vertical PTEX packaged air conditioning heating units in the facade here, vented directly out to the exterior. That's not the most ideal version for us right now. But because we tested it out, we're now working with United Technologies and Carrier to say, I need something better. I need a better heart and lungs and brain for a building. And if I'm going to be producing 3,000 of them a year, I need something that is super energy efficient and works within a similar enclosure. At the same time, you see that it's up on posts, and that was a really specific thing. Each one of these, there's actually 2 chassis bolted together. That chassis that we looked at earlier, our maximum tolerance is about 1/16 of an inch. To put that in a little bit of perspective, our minimum tolerance is 0 inches. So when we bolt these things together, we're bolting a moment frame steel tower together. This is a robust steel chassis, and at the same time, we filled it with the rest of the building. Would you see poking up the top there? Those are registration pins. That's what allows us to hoist these things, to pick them and place them on site. They also do something really neat. They allow you, when you set the next box on top of it, they center the boxes, pull them tight, and make certain that everything is registered the way you want it. This technique, Julien, who designed this system, was working in, as he tells it, and so I'm sure it's full of embellishment, he was sitting in the back corner of Shop's office when they were working with Skanska and Forest City Ratner, building the Brooklyn Tower, saying it's never going to work, you have tolerance error issues, you're going to run into some problems. And so he designed this system. And as he was designing this as a replacement system, if anyone saw those articles, that's when they got to the 11th floor and they realized the boxes weren't aligned with each other. The reason for that was because they were taking construction tolerances from the earth and sort of mirroring them and exacerbating them all the way up. So we wonder then, what does it look like when that is how we do buildings? Now, back to that example I gave earlier, I'd love to imagine new forms and shapes and twists and turns and technologies on buildings. For now, version 1.0 of what we're doing is to replace the buildings we do with much better versions. Internally, we've made a pledge that by 2025, we're going to do 2 things. One is that we're only going to be producing, when it's housing, net zero or net positive housing. And the reason for that is that when we can start to put pressure on all the systems, when we start to think about enclosures a little bit differently, we can actually get there. We're not that far away when you think about everything in harmony. At the same time, by 2025, our agenda is that our good version of product, as it were, is no longer affordable housing. So one of the important things about affordable housing is that that word affordable has a bunch of baggage to it. Most typically, the word affordable means massive subsidization to take the cost of what it usually takes to build a home and shrink it down to what people can actually pay for it. I'm going to refer back to Chicago for a second, but the typical affordable housing project in Chicago requires 14 funding sources. Does that make sense? So from tax financing to credits to rebates to grants to actual sort of money, 14 different places to get all that money together to do an affordable housing project. In San Francisco, they just updated what qualifies for affordable housing. So if you live in San Francisco, as a single person, you make less than $117,800 a year, you qualify for subsidized affordable housing, okay? If you're a family of 4, it's almost $250,000 is what it costs before you can actually go out and buy your own housing. So by 2025, our agenda, starting with Chicago, is to remove the word affordable, because back to those other examples about productivity and efficiency, our expectation is that there's a way to bring better homes to people and bring that cost down. I just finished building a home in Chicago that I wish I would have waited a year or two so I could do it this way. And in the basement, I have 2 things called power walls. Has anyone seen these things, Tesla power walls? They're really awesome. They're 5.5 inches thick. They look like a piece of art. They're 15 kilowatt backup batteries, and they cost $5,000 a box. 5 years ago when I was doing a similar project, that is an 8-foot tall high voltage container full of tractor batteries, and it cost almost $37,000. So when I think about that, I don't think about what Tesla did as sort of ruining the home backup battery industry. Actually, I think it's the other way around. They've brought the technology to more people. They've brought better design to more people. They've changed the way we do it. So again, when I go back to what can happen when you align supply chain, when you think about buildings as products, you start to get affordable housing that looks like this. You start to get affordable housing that looks like this. You start to change the expected narrative. Because if I'm doing 3,000 of those countertops, it changes the way, A, I specify countertops, and B, where I get them from. If I'm doing 3,000 units of high quality lighting, I can actually change the way I light things. I can use new technologies. That example I gave earlier about the power over Ethernet, the research that we're doing right now suggests that if it costs me $1 for a light switch and $3 to $4 for a standard light fixture, so that's $5, okay? It costs me $95 in labor and conduit and wiring to connect all those parts. In the study that we're doing with one of our partners, if I switch to high performance LEDs, it's a $20 light fixture, or a $20 switch and a $30 light fixture, and $10 in labor to put it in. So all of a sudden you're changing the narrative on how these pieces go together. I just radically increased the quality of light. It's dimmable, it's tunable, and at the same time, removed the cost. We have a partnership now with MIT and Autodesk because we believe that those chassis that I was looking at before, our factory, when it's fully up and running in February, is not going to be making chassis, the steel boxes. We've outsourced that to a steel fabrication shop. Because what we're working on right now is back to robot automated welding solutions. We don't actually want to introduce welding in our shop until we find the right pieces. And the really great thing about it is that that technology exists. A lot of the things that we wonder as maybe the next great thing for how our industry works already exists out in the marketplace. So buildings like this can be built entirely off-site. This is 110 units of affordable housing. It's 1 story of podium and 5.5 stories of boxes that are shipped fully finished. Buildings like this can happen from beginning to end in 8 months. That changes the game for a lot of people that are hungry for better design, better opportunity, and a place to put their head. And in places like Chicago, in places like Salt Lake City, in downtown urban centers like right here in Knoxville, there's ways that you can do really interesting, innovative work. It looks and smells and acts and feels very familiar to the people moving into it. And I would argue it's just the start of a better way. So with that, I think I'm going to my phone says it has low battery. I'm going to go back to a hammer and maybe open it up for any questions if anybody has any.
So you said something about 12 units, 12 modular units being produced per day.
Yes, ma'am.
How many employees does it take to do that?
That's a real good question. So at full capacity, single shift is 150 employees for us.
Single shift?
Yes, ma'am.
Do 24/7?
Not yet, because right now it's more pro forma based than actually standing up on the ground. We're just getting everything up and running now. So the analysis suggests 150 employees to produce that number of units. What we're also looking at, and again, maybe I'll frame a little bit for Chicago. Chicago is a union town, which means that most buildings, and especially affordable buildings that require subsidization, require full union employment and full union stack to build them. So what we've done is we've partnered with a couple of the unions. We've navigated a manufacturing labor agreement. And then the important thing about that is that under a traditional model, if I were doing an indoor construction site and I needed the top of this wattle, let's try that again. I need the top of this water bottle taken off. I'd have to ask you to do it because that's not covered under my union. So we've shifted that narrative. And at the other side too, we're creating a pipeline. So we have a situation in Chicago where we have over 100,000 affordable houses that need to be built. And we have some neighborhoods that are 20 and 25% unemployment rates. And so we're sitting there with a massive need to build affordable housing and a massive need to create jobs. And we're fortunate to find a bit of a crossroads. But at that sort of 12 modules a day, that factory will be producing just about 1.25, 1.3 million square feet of buildings. And right now, as we look at what 2019 looks like, we're worried about actually that being enough for the conversations we've had. Yeah?
You said you're the construction company and now you're manufacturing. Are you also the developer for these projects, or do you have outside?
Yeah, that's an interesting question. So we have design in-house, we have manufacturing in-house, we have construction in-house. We've done a couple different things. We haven't brought development in-house yet. And on the design side, one of the ways that I frame it is that if you're a best-in-class designer, we partner. We've got a couple cool partnerships. But if you're not best-in-class, we're going to do that. We're not developing yet, but one of our development partners has kind of said we are because we're now working with banks to pre-finance buildings as products, so that we're covering the finance end of it and allowing the developer, and that's primarily on the affordable housing side. We're basically removing every one of the barriers to entry on the affordable housing side. But on the larger scale, the 6 and 10 and 15-story buildings that we're doing right now, we're not the developer on. Yeah?
How long do you think it'll take before you realize this is going to work, or we have to change it or forget about it?
It's a good question. This is maybe naivety and sort of hard-headedness, is that our expectation is that the industry can't continue to function. I don't believe that industry can continue to function the way we do it right now at a large scale. So for me, for us, we have our sort of 3-year look ahead, but frankly, I don't expect the vast majority of sort of infinitely repeatable products to go back to a traditional way of doing it. I've been asked a bunch of times about that one project in New York City, the 4-city Ratner project, that one project, and it didn't work, so now what? And here's the thing, we're kind of one of the only industries that says it didn't work that one time, or we tried it in the 80s, or we tried it in the 60s, so we're never going to do it again. We're the only industry that kind of acts that way, unfortunately. And at the same time, if you look at New York City has had something like 6 or 7 buildings built in this fashion. 2 of them in New York City, or really New York, and 4 of them from overseas, put on a boat, put on a truck, right? I mentioned Polcom earlier. Polcom has built buildings that are in downtown New York City and now being built in Seattle. So the easiest diagram that I can think of when we talk about maybe what we see in the United States is that if you draw a line around, especially at high rise, at density, if you draw a line around the United States, where you see people building this way is outside of that line. We've mastered, and one of the things I get excited about, in the US, we've mastered lower rise, lower density wood frame structures. examples not that far from here are really solving some better solutions for that. Being based in Chicago, and one of the reasons why you see steel, we use steel, is that we're doing non-combustible high-rise style buildings. Now, that being said, I do have every expectation to shift to cross-laminated and parallel laminated timbers, exploring new materials. But Chicago has a history with this cow who kicked over a lantern and burned the city down. So for us, building stuff off-site was sort of step one. Long-winded way of saying, we've given it a 3-year horizon, but the demand that we're seeing even before our factory's up and running suggests that it's the industry's opportunity to lose, as it were. Yeah.
About your firm, correct me if I'm wrong, but you have, Skander is in San Francisco?
It's San Francisco and Chicago.
Okay.
That's right.
And is this really a Chicago-based initiative?
It is, and the reason for that, Chicago is fortunate because it has unions to comply with, some of the most backwards code and regulation you can imagine. We have 51 mayors that all do it the Chicago way, and I throw air quotes because I think everybody's heard about politics in Chicago in one fashion or another. So for us, and we have climate to deal with too, so for us, it's about getting a process right. And the interesting thing when you shift to a manufacturing focus is that once we get that process dialed in, we're starting to have conversations with other places about where else we might set up that process. For now, we're leveraging all the rules and constraints of Chicago so that to get it right in Chicago suggests that it'll be infinitely easier anywhere else. Yeah.
So I have another question. Didn't Amazon just create its own manufactured housing initiative in LA?
Yes, they did. They acquired a modular manufacturer in Los Angeles.
Say something about that. I got the feeling it's to promote smart products, but they tend to be a leader. And do you see them part as well as you guys? Is this part of a trend?
I would say yes, it's a trend. Now, I used to joke up until they made that announcement that we'd like to have an attitude, especially in certain sectors where you work with somebody to design an object, you buy that object, you swipe your credit card, and Amazon Prime lets you know when it's going to be delivered to your doorstep. But now that Amazon's purchased a modular builder, I don't use that example as much because, but yes, so oddly enough, we've had conversations with one of the other organizations that has smart products in their homes now that Amazon has aligned it that way. If you can think about it, bringing in those smart tools and technologies from the very fundamental building of a box does a bunch of really interesting things, from logistics and supply chain coordination to actually the health and viability of a building itself. And that sort of data and information is becoming more and more interesting. So.
And is the Amazon thing an exploratory pilot?
Here's the thing that maybe we should all be considerate of with Amazon is that everything is an exploratory pilot, which leads to a massive business line. I only say that they announced the Amazon Go store in Seattle a year ago. They propped it up, and now they're building out 8 more of those with plans to build more. So it's interesting. There's another really interesting business case, Katara, and I don't know if anyone's come across Katara. Katara was founded by a number of Silicon Valley investors and a group home developer on the West Coast 2.5 years ago. They're valued at $1.2 something billion. In 2 years. So in Silicon Valley language, that's considered a unicorn. That's the language around it. They're doing panelized construction, so IKEA-style flat pack construction. And maybe the best example goes back to Amazon that I can use is that it was started by somebody from Tesla, an Apple materials person, Flextronics, SoftBank funding. And the joke goes something like a number of tech people were standing in an office in San Francisco looking at a construction site saying, I don't know what the hell they're doing out there, but we could probably do it better. And there is a reality where that's kind of the truth. If we all step back and look at the way we build things, we'd wonder why we do it that way. So I do see it as a sort of global trend. And I'm not, as a designer, I'm not scared about it. I think that there are tools and technologies and materials, things that are happening just 3 miles away in advanced and additive manufacturing and insulation that at scale could radically change the way our buildings work. But they kind of require that scale to get there. Yeah.
Kind of change topic a little bit. I've noticed a lot of discussion lately around removing the designer from the design process
Yeah.
Which what you're doing in construction is building a program that can do that or something similar, something you're thinking about?
One could argue that over 95% of the buildings that are built in this day and age have removed the designer from the process, okay? And I don't mean that to sort of like, that hurts, but that's a reality. When you drive around most places, you don't see the buildings that inspire you and frankly that leverage design to make experience better. There's a lot of crap out there. It's our intention in the same way that when you look back and you say that, just because I've used it, but somebody like Johnny Ive or Mark Newsom or Kareem Rashad, you don't look at them and say they're awful designers because they only produce mass-produced, or you don't look at automobiles and say that there's no design soul left in it anymore. Mercedes is a crappy car because they only produce 6 different designs a year. I think for designers, we have this perception and concern that we're going to be removed from it. But again, literally every other designed object in the industry in the world is leveraging to enhance, right? To use new materials, to use new technologies, and that happens at a certain scale. At least that's my argument. I don't intend to remove design. I intend, frankly, to bring more design to more people. You could say that the notion of modular or trailer style homes is one of the most disrespected aspects of our profession, I would say, over the past 40, 50 years. That was a solution to bring better homes to more people that couldn't afford traditional homes. And we look at that as a slight against design, instead of actually solving a real social need. And my hunch is that most designers, somewhere deep inside, are more interested in solving great social needs through design than fighting for change orders on a construction site. So no, I don't think it removes design from the conversation. I think it actually probably gives design a driver's seat in the dialogue. Yeah.
I was always taught that like the assembly line takes the pride out of like laborers' work and stuff. And so what are you doing in like your factory or industry type of thing to like that happen, the prefab manufacturing?
It's a really good point. How do you have pride in your work if you're doing it on a factory line? And there are examples of factory lines that are soulless, soul-sucking jobs, and there's examples of factory lines where the culture is really wonderful, where people feel like they're changing the industry. There's a company called HEM, H-E-M. It's a Swedish company that makes furniture, okay? The individual, the designer that founded that company realized a couple of things. Half of their design efforts were going to designing IKEA flat-packed furniture, so bringing more design to more people, right? And the other half, so a $100 dining room table to a family that needed a $100 dining room table. That same designer was also designing $10,000 beautiful custom bespoke dining tables that would sell in high-end furniture galleries. And what they realized was that there's something to be said for the amount of design work that goes into solving and the craftsmanship that goes into solving for a table that can go in a box and be shipped from IKEA to anybody's home that didn't exist. It was sort of design for design's sake on this side. HEM was started to sort of find that place in the middle. Maybe the point of that example is there are hundreds of thousands of people employed in the construction process who do not feel like they have a voice or a soul or a position. Somebody who eats their lunch in a pickup truck by themselves and works by themselves or with crews or is visiting 15 different sites. I mean, for me, if I step back and look at that, that is not a path that is about sort of treating them as noble carpenters, maybe the way we'd like to think about it. So maybe that's a way that we're combating it. Right? As an organization, we're fundamentally, and this is one of the things I love about our organization, we have leadership in design, manufacturing, and construction. We also have a leadership in people and culture, and that individual can veto any business decision we make if it negatively impacts the people that work for us. It's an interesting price to pay, but again, it's setting the right culture so that people have the pride of ownership. Truth be told, we'll have to wait and see, though, too, and really understand how it works and how it unfolds. But as I mentioned before, we're working with the city colleges of Chicago. They're the trade schools and the community colleges in Chicago. The Daly School for Advanced Manufacturing, we're partnering with them because my hunch is that I can take a 20th century pipe fitter, and she's worked out in the fields for 40 years. She knows her way around a wrench. And I can sit her next to a 21st century pipe fitter. And that 21st century pipe fitter may actually be driving a computer mouse that runs an automated piece of equipment. So it's less about replacing jobs. It's less about de-dignifying jobs. It's really just rethinking what the next version of those might be. Yeah.
Do you mind in your slide show going back to where you have these modules you were stacking one on top of the other? That's fine, right there.
Yep.
Is each one of these modules autonomous, meaning it has its own hot water, its own electricity, its own lights, its own HVAC? Or are you somehow integrating that all together?
Yeah, it's a really good question. So what we're doing on this building is that every unit has lights, water, electricity, everything is sort of prepackaged. We're trying to figure out, and we're working with Carrie on that sort of heart, lung, brains package on the deal. But they're connected to fresh air supply for the whole building. So part of it is to make the most efficient box we humanly can, and then understand how they work in concert with each other. So to provide a little bit more resiliency, we're going back and forth in the first couple of projects. One is, like this one, is heavily focused on autonomous boxes. And the other building that's being designed at the same time is heavily focused on sort of shared cross-platform systems too. It's a bit of a test for us to see what are the efficiencies in each one of the models and the inefficiencies, as it were.
So each one of these has its own air handler unit or some
That's
type
right.
of heating cooling system.
Yep,
But they're all tied together at a central source.
that's right. And that's fairly typical in mid and high-rise construction. At least in Chicago, right? So that's kind of where we're testing, all right? So what are the redundancies? Now, example on this building, we have continuous exhaust out of all the bathrooms. That goes into a heat recovery unit that pressurizes the staircases pressurize the corridors back pressurize the units. So we originally tried to put all that into every unit to provide full fresh air intake in each unit. We weren't getting the same energy efficiencies that we do when we take a whole building model. But the packaged fan coil units made a bunch more sense in each and every unit.
And the other question, I have two other questions. This one right here in terms of staging.
Yep,
You know, if I'm in a downtown metropolis.
yep,
And there's not much footprint for me. to
that's
put
correct.
Equipment on the side. So are you just driving trucks in and just bringing a couple modules at a time and placing them?
Yeah, so what typically would happen, this is a fairly busy road downtown Chicago. This is a couple blocks from our office, a couple blocks from downtown. The trucks do not fly, although it looks like they're entering, they're shown to be flying. Normally we'd shut off the sidewalk in that first parking lane for a project like this, about 14 months, we'd shut her down. What we're going to do now is actually the site doesn't need to take any of the street or right of way for the podium. The site and the podium are built traditionally. It's a cast-in-place foundation, cast-in-place podium with post-tension slab on top. That allows us to put leveling and centering plates. And then 8 modules a day show up and get dropped on. So the time that we actually close down that street is not 14 months. It'll probably be about 5.5 weeks. Because what we're doing is we are, and actually this came in one of the reviews that we were doing a little bit earlier today. We were originally trying to design without any logistics vehicles, trying to stay within our right, not have escort vehicles. We switched to 15-foot wide modules in Chicago, which require 2 escorts. City of Chicago allows us to gang up to 4 trucks between escorts. So what we lost in, we added another escort vehicle, which is $500 a day for us. We gained in much more efficiency in getting more buildings set at a single time. It also let us create single unit boxes too.
One last question.
Yeah,
This is sort of a thought question.
yeah.
As we are building more modular homes that are more energy efficient and more affordable, we're making it such that more and more people who have less money are able to invest and to get into a nicer home.
Correct.
Which is good.
Yeah.
That's a good thing. And it's improving our industry. That's a good thing too. Building industry is a major industry in our country. Where I'm going to come from is in terms of the energy intensity. Even though we have worked for years and years in improving the efficiency of equipment, whatever the equipment is, what we're seeing is that the use of electricity or the use of energy is going up. It's a paradox.
Yeah.
The more efficient you make it, the more affordable it becomes, the more it gets used.
Right.
and the more energy you use.
Right.
So my only thought here is how can you curb that?
Yeah.
And somehow you got to do some way of power generation.
Yeah.
That each little module somehow is generating power, whether it's solar, providing heating power, something on the air conditioning system. Have you looked at that? Is your plan with that?
Yeah, we have, and I'll use sort of that example of my home real quick. I just built it downtown Chicago. It's a net positive infill house. What we did on it is, what we said was that I switched almost 90% of the electrical load in the house to a separate set. So Chicago, everything runs in conduit, metal pipe that you run the wires through. Not 70, 90% of our wiring is all low voltage, because it already is. Your LED bulbs are low voltage. My wife and I had this conversation. Our TV is low voltage. It just has a transformer. Our hair dryers are low voltage. They also just have transformers on. Almost everything was. So we ran it all low voltage so that we can go to a single high efficiency transformer in the basement. The reason for that, and the reason why we went to a high efficiency transformer, is because we're still working through the city of Chicago to get the PV array on our roof. Once we have the PV array, we just got rid of that 35% efficiency loss that you get by converting from direct current sunlight to alternating current 110 volt. So I say that as an interesting example that we're testing right now with a couple of partners to say, if I can shift to all low voltage direct current systems, if I can now work with our appliance partners to make low voltage direct current systems, now I have no transmission loss, I have no transition loss, I can actually gather sun directly on the roof. The example I gave on my house is an important one because this is downtown Chicago where annualized sun average is 3.12 hours of sun a day. What we're starting to say is, all right, it's not just making each piece of equipment more efficient, but how are they all working together? And then how are we finding the next piece in the inefficiency slide? So you hit a good point. We switched from incandescents to LEDs, right? Everyone is using LEDs now. And while they have their energy rating, it's massively reduced against incandescents, we're still losing a lot of energy in that transfer. We went from very energy consuming PCs, desktop PCs, that pulled a lot of power out of the wall to stuff like this and my iPad, which doesn't use nearly the amount of energy. And to your point, I used to sit at my personal desktop for an hour a day maybe versus having these devices on at all times. So for us, we're trying to navigate how all those streams go together. We have a wonder with a couple of our partners that if I can do water heating and cooling, air heating and cooling, power storage, all in a combined unit, it does two things for me. I can reduce the footprint such that solar power will charge it. And also I can start to produce solutions that don't have to go in brand new buildings. They can now go in renovations and adaptive reuse. But you're exactly right. We keep on making things better and then we quickly spend the capital that we make. So we get more energy efficient and then we go out like my 8-year-old and spend his allowance as soon as humanly possible on more stuff.
Everything you say is a good thing. But my point is this. There are inefficiencies that can be taken advantage of.
Yeah.
What I heard earlier, you're tying all these units together to a central system.
Yep.
That's your condenser.
Right.
And it's just dumping all the heat to the environment.
Right.
Why can't we take that heat and utilize it to generate electricity?
No, you're exactly right. That heat can then go into heating hot water. It can actually go to geothermal-based heat batteries that are stored till late. All sorts of things that we're not doing right now. We've moved the inefficiency to another. Same thing with electric cars. We've moved the inefficiency to somewhere else and haven't quite solved it.
My point to say is energy efficiency and design is great.
Yep.
But by itself, if we don't somehow couple it to a generation,
Yeah.
then we're still going to see increases in energy. Time magazine about 6 months ago showed the number of people in the world who are going to be able to afford electricity or air conditioning.
Yeah.
And it's staggering.
Yeah.
They're saying the amount of quads is going to double.
Right. Right. I think about, I'm going to use Chicago one last time. My electrical company is paying for my house to be 100% solar. The reason for it is that it's cheaper to provide $20,000 in solar panel on my house than to upgrade the infrastructure that they have to upgrade to provide that amount of electricity times 100,000 people. It is, you're exactly right. The generation piece has to be linked hand in hand. And we're hoping that by better aligning a lot of the parts and pieces, we can actually have more cogent argument for why. Yes, ma'am. So the units, right now what we're doing, the units are about 95% complete in the factory. It's only final connections that happen in the field. And so we've moved all those connections so they vertically stack, so we make those connections floor by floor. Corridors are corridor racks, so they're horizontal infrastructure. So we stack up sort of a full floor, and then we drop racks in place. They become the floor of that level and the ceiling of the level below. All the units tie into that. You sort of think about it as sort of a backbone of the building. Facades on this particular one, everything but the wood screening is shipped on the module. And that's a lie, that sort of thin set brick that I was showing y'all. We're doing a hold off on that brick, so when we join these together, we can do a final tape and seam and then put the last pieces in place. The stair towers are prefabricated with stairs, fully finished stairs in them, except for the last rise and run that are on hinge. So we can stack them and then sort of clip them all together. And this is actually one of my favorite stories. We've been talking with 3 elevator manufacturers about prefabricating elevator shafts in the field. One of the 3 said, we could put entire elevators in the factory with your tolerances. Another one said, we can look at that over time. And the third one said, elevators are the most accurate pieces of equipment in a building, so there's no way that your tolerances could be as good as ours. And I responded with, what are your tolerances? And they said, roughly 3/16 of an inch per floor. I said, that's great. You know, our test models are now showing 1/16, our test stacks are. And they said, well, that's impossible. That doesn't exist in the building trade, so we're not going to do it. I happened to walk out of that meeting, and they've been asking me ever since. They've solved it. But I bring that up because now, and this is not for next year, this may be 3, 4, 5 years out, we're now talking with a couple tower crane companies about building entire elevator shafts, putting a tower crane on top of it, using it as the tower of the tower crane, putting a boom on top, and running that as a skip lift. So even before the building happens, in the modeling, the structural modeling, we can do about a 20-story building where we just build a 20-story elevator shaft, put a boom on top, and then build a building around it. So for us, as much as humanly possible, for the first half a dozen buildings we have in design right now, the bigger ones, over 100-unit buildings, we're shipping a chassis out to one of our manufacturing or mechanical partners, and they're building entire heating cooling plants in a box. Doesn't go back to our shop, it goes straight to the site where it gets clipped into the building as well. So for us, and again, it's really driven by the environments that we're in. The more work, I get that shipping air has some money to it, but the more work I push out to the field, the more opportunities I have for failure. I imagine the work that was done on some of the projects yesterday when it wasn't downpouring, or let's say Friday when it wasn't downpouring versus today, means that there's going to be some issues, many of which we'll never know until down the road something fails. So for us, as much as humanly possible in the factory.
Thank you for the great questions, and thank you.
Absolutely. Thank you all.